Hello classes. Today we're going to take a look at working out the law of sines from section 6.1. I've got our law of sines written down here at the bottom, but of course you have those formulas already given to you in your notes that you should have already taken a look at. So let's see if we can work this one out. You'll definitely be needing your calculators today. Make sure they're set to degrees so that we can punch everything out correctly. So I'm given two angles here, angle A and angle C. Definitely if we're given two angles, we can always find a third angle because we know the angles in a triangle add up to 180. So the first thing I'm going to do is find angle B by taking 180 minus 40 and minus the 22.5. So I'm getting my angle B to be 117.5 degrees. Alright. Now let's see if we can find side A. I want A, and I'm using the law of sines here, so I'm going to say A over the sine of angle A. So A over the sine of angle A, which was 40 degrees, is the same as. Now, since I've already got B and angle B, I'm going to use that as B over sine of B. So B is 12 over the sine of angle B, which is 117.5 degrees. So here's our setup. To solve for side A, I'm just going to multiply both sides by the sine of 40 degrees. I'm going to multiply on both sides. So here we go. Multiply by sine of 40 degrees. And that should give us our side. Let's see if we can punch it out. Here we go. 12 sine of 40. Make sure you end your parentheses on that 40 degrees, divided by the sine of 117.5. And again, go ahead and end your parentheses there. And let's see what we've got. I've got 88.696. What I'm going to do is I'm going to go ahead and round. I'm going to round my side to the nearest tenth here. It'll tell you in the homework what to round to. I'm just going to the nearest tenth for this one. So 8.69 would become 8.7 for side A. 8.7 when I round to the tenth. The last side we're going to find is side C. Be careful here because there's a tendency to want to use the Pythagorean theorem. But we can't because this is not a right triangle. So we've got to use something else, and what we're using is the law of sines. Since I'm finding C, I'm going to say C over the sine of angle C, C over the sine of angle C, which was 22.5 degrees. And I'm going to use what I know, which was the same as over here. I'm going to use my B over the sine of angle B. I used it in the first one, I'll use it here too. So B is 12 over the sine of angle B, so the sine of 117.5 degrees. And here's my setup. To solve for C, I will multiply by this denominator the sine of 22.5 degrees on both sides. I'll cancel that out, and then I multiply by sine 22.5 degrees, and that should give us our side C. Let's punch it in. 12 sine 22.5. Again, end your parentheses on that angle. and then divided by the sine of 117.5. End your parentheses again on that angle. I'm going to round to the 10th again. I've got 5.17, so I'd say 5.2 for C. 5.2. And we've solved our triangle. We've got everything that we need. Don't forget that you can still kind of do a quick check. Whatever angle is the biggest angle should have across from it its side that's the longest. So the biggest angle is B. The longest side should be side B, and it is. The smallest angle, let's see, is the angle C in this one. And the shortest side should be side C, and it is. So that's our first example. Let's try another one. Okay. So our next example, I'm going to give you angle A is 75 degrees. Side A is 51, and side B is 71. This one, we're only being given one angle, and if you read through those notes that you have, when you're only given one angle and you're using the law of sines, which is what we're doing today, there's a possibility of being one triangle, 0 triangles, or even 2 triangles. So we're not really sure what's going to happen here until we start to work. And let's see what happens here. The first thing I'm going to do, I'm given A and angle A, so I definitely want to use that. I know something about B, so the first thing I'm going to find is angle B, and we'll use our law of sines. Okay, so I can say A over the sine of angle A, so 51 over the sine of 75 degrees, is equal to B, 71, over the sine of angle B. Since sine of angle B is in the denominator, what I'm going to do here is just use the cross products to solve this out. So 51 times the sine of B is one cross product, and that should equal the other cross product, which is 71 times the sine of 75 degrees. All right, let's solve for sine of B. I'm going to divide both sides by the 51, and that leaves me the sine of B is 71 sine 75 all over 51. Let's punch that out and see if we can get angle B. Remember, when you're finding an angle, that's when you hit inverse sine or second sine. So let's see if we can punch this out. We're going to hit second sine or inverse sine. And in that parentheses, we're going to put in 71 times the sine of 75. Don't forget to end your parentheses on that angle. And divide by 51. And remember, when you started a parentheses on this whole, when you hit second sine, you're going to start a parentheses. You're going to actually end the parentheses on the whole thing as well. So you're going to have to end the parentheses one more time. And that should give you a domain error. Is that what you all are getting? So again, we're getting an error message here. That doesn't mean the answer is error. It means that, well, there's no triangle that will solve this equation, or this triangle can't be solved. So there is no triangle would be the answer. We got 0 triangles for that one.